So now we need to work on how do we graph the whole thing, right? We know how to graph an axis of symmetry. We know how to graph a vertex. So if we can graph an axis of symmetry, right? So you do a dotted line to show where the center of your parabola is, and then you graph your vertex wherever that happens to be. Basically what I want from you guys is I want to have a total of 5 points. That's what I would like. So far, we have 1 point at the vertex, and so we need 4 more points, and that equates to having 2 points on one side, and then the reflect to have 2 points on the other. Here's the cool thing about that. When you get 1 point, so let's say this next point is 1 away on this side, so it's right there. What's cool about that is it's going to reflect, because remember how you fold it on the axis of symmetry and then it matches up on both sides? So if it's 1 away out to the right, then if you go 1 away from the axis of symmetry on the left, you can just match that right up and there is your other point. Okay, so then we do that again and we find another point, and I'm just making stuff up. That didn't even match. How horrible is that? Let me fix that, please. All right, so then I get another one there, and then I'm like, okay, if I go 1 away over here, then it's going to be right there. And once I have all 5 points, I can go ahead and graph the parabola. All right, so that's basically all we're going to do today. Now, of course, while you do it, it seems so much more complicated because there's a bunch of math you have to do to get those points. So let's just try one out. Okay, so let's say our quadratic equation is y equals x squared minus 2x plus 3. Okay, so we start off just like we did on the problems before this. We start by finding our axis of symmetry. So we go x equals negative b over 2a. So x equals negative, and then b here is negative 2 over 2 times a. Well, if you look in front of x squared, there's nothing there, so that means a is 1. So then I get these two negatives cancel, be positive, so it's a positive 2. 2 times 1 is 2, so we get x equals 1. So my axis of symmetry is x equals 1. So I go to my graph over here on the left, and I find 1 on the x-axis, and that's where I'm going to put that imaginary dotted line to help me figure out where the center of the parabola is. Then we find our vertex. Remember, our vertex is just saying we already know the x value, because the x value, this vertex is going to be on this axis of symmetry, and the x value everywhere on here is 1. So I know that all my x values are going to be 1, and that'll allow me to find my y value. So I get y equals, plug it in using parentheses always, plugging in 1 every time I see an x. Do my math, so 1 squared is 1, 2 times 1 is 2, plus 3. And if I do that math, 1 minus 2 is negative 1, plus 3 is 2. So my y value is going to be a positive 2 on this dotted line. Some of the confusion sometimes people do is they put it on the y-axis, because I just counted up here, and so then but make sure you put your vertex on the dotted line there. All right, so that is what we've already done, and then we still have to find 4 more points. So I was kind of hoping those wouldn't be there. Okay, let's see if I can get them out of my way. All right, so let me get that math out of my way here. I don't need that stuff anymore. I've already got that all recorded. And one thing that's helpful, you guys, and I'd like you to get in the habit, is when you do this, go ahead and draw yourself a t-table to keep track of your x and y values, because it just kind of organizes you a little bit here, okay? So what we've just done is we found our axis of symmetry when x equals 1 and my y value is 2. So I'm actually going to put those right in the middle because they're in the middle of my parabola. Then I need to start plugging in other numbers to find my 4 other points. Now, I'm going to give you a really big hint, so I hope you're all listening. One of the best numbers ever invented, and it took a long time to invent it, is 0. I bet you knew that because I talk about it all the time. 0 is awesome, and here 0 is going to be extremely awesome, because what we're going to do is we're going to plug in 0 for x, because that's what you're doing. You're picking an x value and you're finding a y value using our equation right here that we have. Okay, so if I plug in 0 for x, using parentheses always, I plug in 0, I plug in 0, and the coolness about 0 is 0 squared is 0, and 2 times 0 is 0, and so really we just have 0 minus 0 plus 3, we just get 3. So we plug in 0, and we get 3. So I go over here on my graph and I find 3 on the y-axis. I just plugged in 0, so technically I'm finding the y-intercept, right? And if you remember, this is 1, this axis is symmetry, so I'm 1 away from the axis of symmetry. So I'm going to go over here to 2. That means x is 2. And the y value is going to be the same because it's going to match up. So the y value is going to be 3. So on my table, I can actually put a whole nother point on there because I'm kind of like, I almost feel like I'm cheating. I'm just reflecting it over, right? Just like the butterfly wings if we fold it in half. So I've already got 3 points. Remember, I need 5. I need to plug in another number. Now here is where a lot of people go, okay, I plugged in 0, Strom, now what? And they're like, I don't know what to plug in next. Well, it's kind of your choice, you guys. Look at what you already have. We already have 0, right? There's that point. If I look at my x-axis, I already have 1. It's the vertex. I already have 2. It's that reflected point. And so now I just need to pick something that's not 0, 1, or 2. So we could go to 3. We could go to 4. We could go to 5. We could jump up to 10 if we really wanted to. That would be silly, though. I actually wouldn't go any farther than just 1 away, because if you go any farther than that, the numbers tend to get pretty big, and then your graph doesn't fit on your graph paper and you'll get annoyed. So don't go too far. So we could go to 3. We could also go this way and go to -1, -2, -3. If you can stay away from plugging in a negative number, I would recommend that, because typically when people plug in a negative number, it's easier to make mistakes with that squaring part and making sure you square the negative. So if possible, I try to stay positive unless my negatives are easier numbers to work with. So in this case, I'm actually going to plug in 3. So still the same equation. So we're still using this equation here, but I'm plugging in 3 for x. And so 3 squared is 9. 2 times 3 is 6, plus 3. It's a pretty big number actually in itself. 9 minus 6 is 3. 3 plus 3 is 6. So when we plug in 3, we got 6. So we're at 3, 4, 5, 6. I plugged in 3, so that point matches up right there. And then we can reflect over. So when I look at this, I'm at this point. I go over 1, 2. That gets me the symmetry. That means I need to go 1, 2 over, and that will give me my reflected point, which happens to be at -1. And so then my y value is still going to be 6 at -1. Now, if you don't trust that, if for some reason you feel unsure about that, go ahead, and if you plug in -1 for x, you will find that you get 6. Now, once you have 5 points, so you've got your table, it's got 5 points, you've got your graph that has 5 points, you go ahead and draw on the parabola. Make sure it's nice and round. You don't want any points on this. Parabolas are just nice and round. They're not jerky. If you happen to have something that looks like this, and so it's really hard to go nice and round because then you have to splay out again. Is that a word, splay? But if you have to go out like that, here's what my guess is. My guess is if it looks anything like this one, where it kind of goes out again, because it's not supposed to. It's supposed to go like this, nice and round. If it does that, then my guess is you got the wrong axis of symmetry in the first place. You probably messed up with a negative somewhere. And so I'd go back and double check your work on axis of symmetry. And then usually what happens is you'll move that over, and then your parabola will look real nice. If that does happen, though, don't get rid of all your work. Your work is still worth something. The points are still what you plugged in. You'll still get the same y values. It's just the reflections that you'll have to change. I'm not going to do another example because I feel like this one was enough. And if you need to rewatch it, then go ahead. But I'm not going to make you guys sit here through another example when you could just rewatch this one. All right, good luck.